they have a shared backplane for power and for internal connectivity. And then again, it's liquid cooled. With liquid cooling, you have immersion cooling where you basically throw the whole thing in a swimming pool. You put a heat sink on the processor, and instead of a big fan sitting on top, it's actually two hoses. So it's the cold liquid in, it pumps across the heat sink, and then the warm liquid comes back out where it gets cooled.
Welcome to another episode of the Cloud Gambit podcast, where we translate technical jargon into fine art. Now, every art gallery has got a curator, and that is me, William. But with me is my co-host, the Picasso of creativity, the Da Vinci of intellect, the Claude Monet of tech wisdom, Yvonne Sharp. How are you doing today?
I told him in advance he had to make me an impressionist, not a modern artist. And he led with Picasso. But that's okay. We'll forgive him. It's okay. If you come to my house, it's all impressionist all the time. If you look behind me, you can see Monet's Woman with a Parasol. Just so you know, like, it's impressionism for the win is my jam. But anyway, today we have the irreplaceable Pete Lumbis with us. And Pete and I think I met Pete back in his Cumulus Linux days when he was doing white box networking. He's a fabulous technical storyteller and one of my favorite folks in the industry. So thrilled to have him here today. How are you, Pete?
I'm doing great. Thank you. And Will, I think you painted a great picture with that intro.
Thank you.
We are already cooking with the dad jokes today. So this is going to be a fun one. You gotta have
fun on these things sometimes. It can't just be all business. It's, you gotta have the mullet,
Yeah. Business in the front, party in the back.
Yeah.
Oh. Well,
Mullets are coming back, actually. Surprise! So I was actually just at a hockey tournament over the weekend in Miami of Ohio for my son. I saw more mullets on young boys than I've ever seen. Like every four, maybe one out of every three kids had a mullet.
I'm not going to
very popular
hairstyle. Have any knowledge of youth trends, but I'm also going to say mullets at a hockey game in Ohio, we've got some selection bias in there.
Did any of them know who Billy Ray Cyrus was? That's the question.
Yes.
Yeah, that's funny.
All right. Well, Pete is now in a new role at NVIDIA. Love to hear a little bit from you, Pete, just about your career trajectory, what you've done. I know you spent some early days in Cisco TAC, where you cut your teeth, CCIE, CCDE. So love to hear a little bit about where you come from in the industry, and then we can dive into some NVIDIA fun.
Yeah, I started out of college at Cisco in the TAC. Spent a year working on firewalls, realized I was not very good at that. And moved over to the routing team, focused on routing protocols. Moved up from taking cases to team lead to part of the global escalation team. So if it was really broken and it had an IP address, it was probably my problem. Along the way, not only learned a lot of the routing protocols, software configuration, things like that, but a lot of that kind of hardware software interface of networking devices. How are we programming ASICs? Why is this ASIC not working as well as the other one? I also had the misfortune of working there when the NXOS line came out. And so then I learned a lot about operating systems and operating performance when people would replace their 6500s with a Nexus 7000 that was, supposed to be twice as fast and 3 times as awesome. And it would just fall over because of a bunch of different operating system architecturals that I think they eventually fixed all that stuff. But, those early products were some rough bugs in there. So I did that for a while, ended up going to Cumulus Networks. As you mentioned, they did white box switching. So we took a Linux distribution, put it on a switch. You log into the switch, it looks like a 48 port Linux server, but it's a switch running, 48 ports of 100 gig or whatever. I was a post-sales consultant. I was a pre-sales engineer. I was a technical marketing engineer. I ended up running technical marketing at Cumulus. Then we got acquired by NVIDIA. I suffered a little bit of burnout. I had to take a step away, went to a startup to do tech docs, and now I'm back at NVIDIA helping them work on their multi-node AI systems, where you basically buy a whole rack of stuff at a time as a single unit.
Very cool. So one of the things, and if anybody's been listening, they know I've been talking about this quite a bit, but that I really believe in the technology sphere. We're entering a new age where hardware is on the ascendancy. We went through a period of time where really from a compute hardware perspective, you just bought the latest, greatest, fastest x86 processor that was available that your budget could afford. And then you didn't think much about it anymore. You put your operating system on there, and then you moved on to the cool software stuff. I really think that the world is changing where that hardware is mattering more again. I'd love for you to talk more about what you're seeing in the industry, and especially as that results to cloud and networking.
Yeah, I think it's pretty clear that the hardware is coming back in vogue. I mean, you can just look at NVIDIA's earnings. I think it's pretty obvious. But I think really what we're seeing is just as you said, like software was the rage a few years back. I think really what happened is we grew the software ecosystem both from languages, like with the creation growth of things like Python and Java, making it easier to develop, and the growth of the libraries that made it easier to build things on top of those. So it really accelerated that learning process of software. I think we're seeing something similar with hardware, where now we have so many more things in that hardware that we can start to do crazier ideas. And what I mean by that is the idea of processing the amount of data that we're processing now in some of these like AI clusters, right? Where we're doing full throttle for months at a time for training, that would have been impossible without the advances in the hardware. And those advances in the hardware to make this something you would think about would have been impossible without the advances in the software. And so, like everything, it's the pendulum swinging, kind of just swinging back towards hardware. But, absolutely right. Like, hardware is coming back, and it's not just about clock cycles. It's about performance at every step. When people are wondering like, well, the PCIe bus is too slow. Well, 400 gig Ethernet's too slow. Well, the latency from port to port on the network switch is too slow. Like, it's kind of a crazy space that I don't think most folks have ever really thought about or been in before.
So, sort of like you all were discussed. Sorry, Yvonne. Let me spit something in here. Software, you all sort of just laid out. It's kind of been eating everyone's lunch, especially since cloud blew up. At this point, like even on the market, like software engineers are, saturating the market, and software is getting pumped out like, Arnold pumped weights at Gold's Gym in the 70s. Just software. I don't know why I even said that. That's terrible. Whatever. But anyway, hardware, like especially the type of hardware companies like NVIDIA, that what they're producing, like the demand is so unbelievably high, and the quantity required to do what the hyperscalers are trying to do, it's crazy. I just read an article this morning where I was talking about, like, I guess Larry Ellison and Elon Musk were at dinner with Jensen, like begging him for GPUs, like over dinner. And I guess just kind of like where we're at in the demand and the type of companies that are the purchasing power, I would say that they have, like, is this sustainable? Like, how do we keep going at this rate?
I think the answer is yes and no. Like, of course it's not sustainable, right? It's an insane period of growth. But I also think that it's a time where, like, I think back to like maybe like the early 2000s. I don't know if this is totally the right spot, but like every processor that came out, it was kind of the same thing. Like, the processor speeds were so slow compared to the needs that we had that we were willing to put it in the trash every 12 and 18 months because the new processor made such a humongous difference. And we're seeing that exact same thing, right? If I buy, my math is going to be wrong here. I buy 1,000 GPUs and it takes me a month to do training, and I can throw all those away and buy 1,000 new GPUs and it now takes me 2 weeks. That's a huge amount of money that I just saved. Or I can double the size of my model or whatever and make it even more accurate and better. And that's where I think we are, is that kind of coming back to Yvonne's point, like the software has enabled us to create this kind of ridiculous problem to solve. And now the hardware is trying to catch up to solve that problem. And look, I don't know when we're going to get there, but at some point it'll just be like the CPUs, right? Like the next CPU that comes out from Intel or AMD, like, okay, cool. But I'm not like, generally, I'm not dying to go get that next upgrade every 12 to 18 months. We'll get there with GPUs as well. We're just, I think, still very far away from that, just given the problem space that people are working on.
Love that answer.
Well, and so you mentioned that, when you cut your teeth in tech, you really gained an understanding of that intersection of software and hardware, especially in network gear. And a lot of folks who've grown up in the industry to this point haven't really thought much about that software hardware interaction surface unless they have been developing kernel drivers or something like that. Can you talk about how would somebody educate themselves on those interaction surfaces and learn more about what's important to know about that hardware software interface?
I don't have a great answer for this, unfortunately. I mean, I still find myself struggling to learn and like figure out the right place to start. I think one of the challenges here is software people can't write about hardware, and hardware people can't write about software, and you're trying to find the thing in the middle, and like, who's writing about that, right? And so you kind of have to glom it from both. I think when you look at textbooks around like computer architecture, for example, they start to get to some of this. I find some of the presentations on something like hot chips or I can't think of the other one. There's another industry like academic conference every year, or a couple times a year, that provide these papers. You can go and download them and read them or watch the YouTube videos. And some of them I have absolutely no idea what they're saying. And other ones, like, I'm getting 60%, and that's pretty good. And that 60% allows me to grow a little bit and move forward. And I think a lot of times it's me kind of circling back over and over again and being like, well, wait, did I learn something new that applied to this old problem that I had? Does that make more sense to me now? Do I understand how these things apply that I didn't get before? But I have personally found it very challenging outside of like having a thing on fire in front of me that I've had to dig through to understand. It is a place where I think mentors can be a lot of help, right? So you have somebody to ask some of those questions to and provide you some guidance. But again, it's tough because there's not a lot of folks out there that live in that intersection.
Yeah, that's one thing. Like I've actually gotten lots of questions in the past few months of like, you have this big AI thing. How do I get into it? And I'm like the last person you want to ask that, because I've probably had too much fun and spent a little bit too much money. Like I have an ITX motherboard that supports 8x8 bifurcation. I have like Gen 3 or Gen 4 bifurcation adapters. I can split that 16x in half, and I can have multiple NVIDIA 3090s running, and I'm doing my own voice training in like my basement. And these 3090s run like toaster ovens. So I had to rip them apart and do new thermal pads and all this stuff so they didn't like catch on fire practically. And I walk through some of this with folks that are just trying, and they're like, yeah, that's crazy. I'm not doing that. Like, what else? And I don't have any other answers, because honestly, with network engineering, this is the way I learned. I had to go buy a bunch of junk on eBay and then learn some stuff and then resell it. And there's a lot more virtual stuff now, better ways to do that as far as learning is concerned. But we're such in the early days that there's just not a lot of options because it's so compute intensive.
Yeah,
I don't know what the easy way is to get into that learning.
And I think part of that's just, again, like you said, it's early, it's timing. If we look back to, the early days of computing, everybody that was a computer scientist was doing this kind of thing, right? They cared deeply about both the hardware and the software, and they had to know it because the software had to perform at the speed of the hardware, and the hardware was so tiny and limited that you were trying to figure out these crazy tricks just to make it work. And as the hardware, got large enough and fast enough, you could just be lazy right? I think about like, again, Python, I think is a great example where, you know, performance heads are like, well, Python's terrible. Why would you use Python? Yeah, it is. Also, I can write code twice as fast and with half the number of errors. And that's the trade-off we make. And I think that, you know, we're at a point where, just like I was saying, that the hardware is still so limited from a resource perspective, not just in availability, but from the resources, that we care deeply about every tiny little knob and every place that there can be friction. You know, we haven't made it to the point where there's, you know, space or like more than enough hardware that I can be a little bit inefficient and get it done. And I think in the future, that will absolutely happen. I mean, there are people today who are, you know, writing their applications in CUDA or PyTorch or whatever. They're hardware accelerated, and they just kind of let the hardware be the abstraction, and it goes away. There are people who are super focused on the hardware performance, and they don't know anything about the C libraries that live above that do that parallelization and processing. And so, like, you can find that niche. You know, it is a huge space to be able to do all of it. And I think, again, that kind of comes back to that challenge: is you can try to be the person that does it all, but it is going to be a lot. And so I think, you know, just like anything, you have to find an area to try to focus on and grow in that domain, and then figure out an appropriate time to pivot to the adjacent space and start growing in that domain.
So in your role at NVIDIA right now, you're sitting in this interesting space between hardware and software, and there's a lot of interesting stuff going on related to data center deployments, how we're deploying AI hardware in data centers, and all of that, and that's, you know, sometimes when I talk about this shift of focus on hardware, I think sometimes people interpret that to mean that everything's going back on prem. And that's not necessarily what I mean. I mean that people are going to care more about the underlying hardware wherever their workload is running. And they're going to be looking at that more deeply. Can you talk a little bit about what you're seeing in data center technologies around AI computing, smart NICs, all of that fun stuff?
Yeah, I think first on talking about, is it all moving back to on-prem? Like, I think, one, it doesn't necessarily make sense for a lot of folks. Two, as the hardware is getting more specialized, the running it's becoming more specialized with things like liquid cooling. We'll go more about that in a second. But then three is availability, right? Like, it would be great if you could go get 100 GPUs, but you can't. And so go rent them from AWS. Or
Google.
GCP or whoever. Yeah, exactly. I was working alphabetically down the list.
Okay.
But I do think that there's also just a lot of complexities that are coming in these new systems. The systems I work on, you know, this is all public information. They're called the multi-node NVLink systems, or the NVL 32 or 72 or something like that. And it's a rack of equipment that is cold loop liquid cooled. It has an integrated power bus bar, and basically you turn the whole rack into like a chassis router kind of thing, and every compute node becomes a line card in that chassis. So they have a shared backplane for power and for internal connectivity. And then again, it's liquid cooled. And so with liquid cooling, you have immersion cooling, where you basically throw the whole thing in a swimming pool. That's not this. And you put a heat sink on the processor, and instead of a big fan sitting on top, it's actually two hoses. So it's the cold liquid in, it pumps across the heat sink, and then the warm liquid comes back out where it gets cooled. But now you have to have the ability to deal with that. What happens when there's a leak? How do you deal with the pressure? How do you deal with problems? I ran into a problem the other day. Our coolant was too cold. And so it was not having enough time. It was too cold and going through too fast, and it wasn't having enough time to actually absorb enough thermal energy off the chip. Basically, it's just going through too fast, right? And so that became a problem, because underneath that heatsink is a little credit card sized piece of, it's not plastic, but think of it like plastic. It's something kind of firm, maybe like a a fruit leather kind of thing, and it has to melt to turn into the thermal grease that you've put on a CPU. Well, if your chip doesn't get hot enough because your liquid's blasting through too cold, it will never melt. And now, if you crank that thing to 100%, you will have thermal shutdown before the little piece of paste melts. And so you're like, okay, well, how do I fix this? Well, I actually have to run the water through the pump slower so that it has more, it has another couple of milliseconds to sit as it passes over that chip to allow that chip to heat up and to pull that heat away. And it's like, they're just very weird problems that.
So you can cool it too much is what you're saying.
Under certain circumstances, right? And
yes.
Like after they've done this thermal setting thing that, usually happens in manufacturing, isn't necessarily something you have to deal with in your data center, but, it can be a point where you're like, oh, it's too cold and it's not getting to where I need it to be to actually like get established. And you're like, what a dumb problem. Like, again, having never dealt with liquid cooling, never in a million years would my answer to why is it having thermal shutdown been, it's too cold.
It's really an interesting problem. And that makes me think of like, first of all, the AI hardware pipeline is gigantic, and each part of it seems to be like really specialized, like you were saying. Like many, I talked to a lot of folks that are just like, oh, it's just all GPUs out there, which are mostly used for the training, maybe some inference as well. But now you also have like these TPUs, for which are optimized for like TensorFlow, and you have DPUs for offloading like the network and storage madness from the precious CPU cycles, and then NPUs for edge. To, I guess, on device AI load. So this is like such a different world, as you were sort of portraying there, than what like large enterprise size companies are accustomed to doing in the past. They haven't done anything like this. Do you think this will be a play for actual, when we think of like Fortune 100, Fortune 200 enterprises, or is it going to stay with like these hyperscalers and startups that are already buying these things in bulk, that are really focused on this big data and big training?
I think that, it's cloud 2.0. If we go back 10 or 15 years to the growth of the cloud, everybody's like, oh no, the data center's dead. And the same number of people are like, oh no, the cloud is way too expensive. It doesn't make any sense. Well, different use cases, different needs. And just like every large enterprise probably has some amount of cloud footprint, it will be the same thing with GPUs, right? Some random large bank will have a set of GPUs in-house that they do for certain things. They're going to have a bunch of other stuff in the cloud that they do for other things. And it's going to be probably per project, per group or organization. It's going to be about security needs. It's going to be about data locality, which is a whole nother can of worms. Like, okay, I want to try to detect credit card fraud. Let me train it on every credit card transaction we've ever had. Oh, wow, that's a ton of data. That's not in the cloud. Maybe I'm going to build that on-prem because that's way more reasonable. And I think that, anybody who's been paying attention to computing for the last 10 or 15 years, like, if you think it's going to be all of one thing, you're betting wrong. You can try to guess the mix. I don't know what that mix will be. Maybe it will be 70-30. Maybe it'll be 80-20. But it's definitely not going to be 100-0.
Well, I think the thing that I'm observing anyway is that we are still in very early days when it comes to the AI use cases, right? Our hyperscalers have led the way in having tons of user data. Like if you think of Google, they've got 8 to 10 products that service 1 billion users. That's a ton of data. And that's part of the reason that technology was born in those kinds of environments, Google, Facebook. But now as that technology becomes further democratized, we're still discovering all of the use cases in, I say smaller in air quotes, because they can still be incredibly large data-rich environments, but smaller than 1 billion users, right? And so I think we're going to see this entire space evolve over time And it is going to become more accessible. There will be specialized skills associated with it, but over time, the market will find solutions to real problems that people are willing to spend money on. I think that's the thing that we can always count on. It's just, it's still so new. We're still trying to figure out what all those use cases are.
Yeah, and I think if you look across like the NVIDIA portfolio, that's kind of the philosophy of Jensen's CEO is, look, everything can have some sort of AI machine learning thing attached to it, and maybe we're just not there yet. So whether it's computer vision, there's this whole thing I think is really fascinating called Omniverse, which was related to the whole metaverse thing when that popped for like 11 seconds. But the whole idea is like I can build a scale 3D rendering in, say, AutoCAD, in a virtual environment. I can apply a AI physics library to it, and then I can like open and shut a drawer on a desk to see how that's going to behave. And then I can take a robot arm and have it learn how to open and shut that drawer in the virtual environment. And now I've just trained a robot arm software that I can then go deploy on an actual physical robot that opens and shuts drawers, right? So like, kind of to Yvonne's point, like there's so many things that we haven't even started to understand what is possible. We're really just starting to scratch the surface. And I think if like our two big things in AI right now are text and language and imagery. And it's because we have this humongous, well-labeled corpus of data for that. And I think that as more data sets become labeled and, usable by these kinds of things, it's going to explode into areas and spaces that we've never thought about.
Well, and
yeah, there's a lot of go ahead, Yvonne.
Well, I was just going to say that what Pete has described, the terminology that we're using in the industry for that these days is a digital twin. Like, how do I create a digital environment that mirrors a physical environment so that in some way I'm reducing the amount of effort it takes to manipulate, understand, learn about that environment. So if you haven't heard about digital twins, you will, because that's another one of those, terms that we're hearing in the marketplace.
Yeah, speaking to the innovation, you're just a lot of innovation there's a ton of innovation that we don't even know. Just the possibilities seem endless. And one thing that I thought was kind of cool, seeing sort of unfold is like the acronyms kill me. The Ultra Ethernet Consortium has been just gaining like a ton of traction in recent weeks, and we saw Tesla joined. And thank you for peer reviewing that blog, by the way. Really nice of you to take the time to do that. But
you're welcome.
Tesla's been socializing their take on like adapting Ethernet for Dojo, where they're basically like solving the lossy resync issues with their own homegrown protocol that they coined is, I know PoE, hold on, Tesla Transport Protocol over Ethernet, TTPoE. We do a terrible service with all these acronyms. But so they basically offload TCP to what they call not a smart neck, a dumb neck, in the spirit of commodity hardware at scale. So now we've seen like NVIDIA also joining the Ultra Ethernet Consortium as well, which is awesome. There's a ton of companies on that list now. I feel like a new one gets added every day. But to me, all these things are really awesome, and it's especially cool seeing like unique takes on existing technologies. Rule 11 and companies coming together to aim for something bigger, like bigger standards, and like really, hey, like that we're at the ground floor on this. Let's try to do some good service, for the future. What are your thoughts here? And do you think Ethernet will eventually potentially maybe reign supreme?
I mean, betting against Ethernet is a terrible bet. Like that,
100%.
Ethernet will win. I don't know when Ethernet will win. Ethernet will win. The challenge that I think, coming, like you said, Rule 11, right? RFC 1915, Rule 11, like everything is old is new again. InfiniBand provides lossless fabrics by signaling for congestion. That is exactly what we did for voice before. It's exactly how we did circuit switch networks with things like ATM. Do you have the bandwidth available for this circuit to establish before you establish it? Back then, the definition of a circuit was like an end-to-end T1 connection or whatever. Now a circuit is, a flow of packets as you send from one memory buffer to another. I think that I don't know what Ultra Ethernet is going to look like. They haven't really come out with anything technical. I'm not shaming on them. I don't know what it is. I don't know how they're planning to solve this problem. And I think one of the biggest challenges is, like a classic challenge in computer science, which is decentralized versus centralized. And so in something like InfiniBand works because you have a central controller that can kind of provision and monitor everybody. When you go to the Ethernet side, you can get exactly the same thing from Ethernet today with RDMA over converged Ethernet, Rocky V2, but you have to do a whole bunch of buffer tuning so that the network can signal back itself. And that buffer tuning is hard and it sucks. And it's kind of like if you've ever had to do QoS on voice circuits way back in the day, if you get that voice queue too small, you're going to start dropping voice packets and it's going to be a problem. And if it's too large, you're now going to start starving out your data streams. And doing Rocky is kind of the same thing. And so I'm just not sure what they're going to come up with, where that lives. And then there's also a whole challenge of how do I make it fit within existing or very small modifications of new generations of hardware? And that was always a challenge with a lot of these new protocols that came out in the beginning of the overlay days. Was they're like, hey, I have this great idea for an overlay to replace VXLAN. All you have to do is build a new ASIC and a new network process, a new NIC to make it work. Well, guess what? Nobody's going to buy that because I want to use the thing that I already have and already works and just kind of figure out how to shoehorn that in. And so that's where I'm very curious. I am not an IEEE person, nor am I nearly qualified or smart enough to do that. So I'm not saying they can't do it. I'm saying I have no idea what that looks like.
Well, first I'm going to say if Pete is not qualified or smart enough, I don't know exactly who is, because he drops all this stuff like it's stuff that we all just know. And most of us are taking notes and going to go look up terms after we listen to this. So that's the first thing.
My mind is continually blown by NVIDIA as a company and how they've pivoted. And it's pretty amazing. Even when NVIDIA bought up Mellanox, I was like, wait a minute, what? I did not. It's crazy to me at the time. And I was listening to this, it's called The Acquired Podcast, where they had Jensen on. That episode was so great. I'm going to put the link in the show notes. If you haven't listened to this, these founders talk to Jensen about, this is one of the things they discuss is the $7 billion acquisition of Mellanox in 2021 or something. I can't remember, somewhere around there.
2020.
Just to kind of give them the full end-to-end AI stack, including the network. And just a lot of foresight there. Because, if you think about that deal and the thoughts of that deal getting completed and the value and just going through all the different things you have to go through with such a big acquisition, it was happening in long before 2021 or 2020. There was a lot of foresight there. And that's where you have, that's why you have visionaries out there. It's almost as if they have a crystal ball and they can see the future. Because if you would have talked to me back in 2018, 2019 on the impacts of LLMs and what ChatGPT and these large language models were going to enable for our future, I would have not been on that. It would have not been something I would have seen coming.
It would have sounded like science fiction, a lot of it.
There you go.
Right. And I think one of the things that's really interesting in listening to Pete talk about the industry right now is it's been a long time since we've been in a position as an industry to actually need new protocols. And I think, you think about the protocols that the internet uses every day, whether it's IP, TCP, UDP, all of those protocols have been around in some form for, dare I say, 50 years or more. Don't do the math. It's depressing. But they've been around for a long time. And I think the the emergence of new protocols to solve these new problems is really exciting. And I think it's easy for us to look at the industry and go, yeah, it's just the next thing. And it is the next thing, but it's pretty big. It's a big thing. That's an inflection point more than even what cloud was, a decade ago.
Yeah, thinking about the kind of, another thing I wanted to discuss, and I don't know if it's maybe appropriate to the larger context of this conversation, but something Yvonne said earlier got me sort of thinking as far as like the industry is concerned, as far as like what is AI, ML, all these things actually going to be as far as like the market and like money making products, because you have to, if you're building stuff using AI and you have all this underlying compute that's really expensive, you have to have an ROI. You have to keep your business going. And what I've seen a lot of from the bigger, the hyperscalers of the world is they're taking their existing product suites. They have a lot of cool stuff that they're already doing, but they're augmenting what they already have with AI. Yeah, there's some new things as well. But a lot of like the things that I've actually found valuable are, okay, the existing things they already had, but now I'm interfacing with it through like a Gemini or something else. Do you think that this AI stuff right now is more of like a feature to existing products as we're finding our market fit? Or are you actually seeing like AI first, AI centric companies that are like making it, that have figured out that ROI compute investment?
I don't think that in my limited scope, have seen an AI first thing that is flashy and cool. And what I mean by that is, look, ChatGPT is flashy and cool. DALL-E is flashy and cool. The thing that makes the movies instead of images, like, that's incredible. What I think you're going to see is the AIification of existing things that kind of totally change how people operate in that kind of domain specific way. So for example, if I'm a game developer and I'm building a world, I don't want to paint a bunch of trees. Why don't I have AI generated trees? Right? Like, that's a very simple, like, high impact thing. Or, being able to, again, take that creativity and use it within a game rendering engine to tweak the trees using, verbs or just language, right? Like, more leaves, taller, skinnier, a little more orange, like it's fall time, right? And then not just building a tree, but building a whole set around that. I think about something like, I know somebody who plays Dungeons and Dragons, a friend, and building maps in Dungeons and Dragons is really hard and extremely tedious and time consuming. And that would be exceptionally easy for an AI engine to generate, like, very rich, detailed world maps for something like Dungeons and Dragons. Is that going to change the world? Is it going to be $1 trillion industry? No. But I think what you're going to see is a whole lot of these places where it's highly impact in almost a tailored domain specific way. And I think what's special about ChatGPT and DALL-E is that everybody understands that. Not everybody understands the problems of rendering in game engines. Not everybody understands the problems of making maps for Dungeons and Dragons, right? Not everybody understands the problems of medical imaging, right? But everybody understands autocomplete. And so I think that they get the attention because of that. But I think really where all the money is going to really start to happen is going to be, like, it's just going to get sprinkled everywhere like glitter, in both a good and a bad way.
It's process improvement. It's removing toil. It's making processes more efficient. And I think about, like, when I was a child and went into a doctor's office, there was a row of charts that existed, and they had special shelving systems, and they had, organizational systems for all of those physical paper charts. And over time, those physical paper charts have gone away. right? But it's taken a couple decades for that full transformation to happen. I think we're going to see the same kinds of changes, and a lot of them are going to happen that way. You're going to introduce a thing. You're going to have some early adopters, jump onto it, make it better, and then in a couple decades, we'll look around and go, oh, like we used to write our own cover letters, or we used to like go in and manually format our spreadsheets. But it will be, by and large, I think those are the kinds of transitions that we're going to see. There will be some really cool stuff, but I think that's really where a lot of the optimization and value is going to be, is in the boring stuff.
Getting those fax machines out of all those medical offices out there. Let's go.
Preach.
If AI can do it, unleash the AI.
That will be an event. I mean, that's, I can't imagine the amount of rage that will be just relinquished from the universe if we can remove fax machines.
I had to send one last year still, 2023.
Look, the
I
problem,
literally had to fax something.
We're blaming the wrong thing. It's not the fax machine. It's digital voice that makes fax machines terrible. Look, really, we just need to wind the clock all the way back to analog phone lines, and the fax machines are just fine.
That is one potential solution. Pete, the problem solver.
That sounds. I think my wife has said that to me. It's like, that is a potential solution. It's not the one we're going to do, but it's one.
Yeah. Gold star. Like there are no bad ideas here, right? Is that the conversation?
Exactly. Yes, exactly.
No bad ideas. There's never a bad idea.
Or bad opinions. William and I had that conversation earlier.
No
today,
bad opinions out
we,
there.
We digress. So the other thing that we talked about planning for this conversation was really about power consumption. We're talking about, we've been talking about, infrastructure and hardware and software and how those things interact, but there's a key component required to make all this stuff work, and it's power. What are your thoughts on our power infrastructure and what that's going to look? Are we going to optimize to the point where it's not a problem anymore? Or do you think we're going to need a lot more energy in the coming decade or two?
I mean, we're going to need more energy. Like, there's no, I don't build chips, so I don't know what the state of the art is for, energy efficiency and what we can do. But I mean, GPUs are still in the place that CPUs were a few years back, where like we can still fit more transistors on a die. And as long as we can do that, it's going to get faster and it's going to take more heat, more power. Full stop. Right. And so our limiting factor is that resource consumption and availability. And so how do we solve that? I don't know. I mean, we're going to have to look at a bunch of renewable stuff. I think there's going to have to be a lot of battery technology, because the other thing is there's, whatever a GPU takes 900 watts. That's 900 watts peak. So it doesn't take that idle. But also, I just bought this big expensive GPU. Why am I leaving it idle? So like the energy planning for that, I think, is also really challenging. And how do you kind of absorb the shocks to the system? I think that there's a really interesting article that came out, I think, over the weekend about the XAI data center in, I want to say, Tennessee, that couldn't get the power, so they just got a whole bunch of generators. And, the local government's like, I'm not sure you're allowed to just run a bunch of generators off of gasoline full, 24/7 in the middle of this field.
Are those diesel? Are they natural gas?
Yeah, but it's like, that might not be the right solution to the problem. I don't know what it is, but I mean, I think that train is hurtling down the tracks. Everybody points to Amazon buying the power plant, to be able to co-locate data centers next to it. I think you're going to start seeing things like that. I also think that, Yvonne, you talked about market forces earlier. I think this is a monumental market force that is going to start to change energy policy in America and in the world, right? I think that you're going to have to start thinking more about whether it's, again, very large scale batteries, not thinking about things we've thought about before, but like pumping water up a hill using solar so that it can be treated as hydro coming down the hill at nighttime, or looking at atomic energy. I don't know what it's going to be, but it has to be something. And
China's really gone all in with nuclear. I think I was reading something. I'd listened to something on a podcast like a month or two ago, and then I was reading some follow-up stuff, and I forget how many nuclear reactors they've committed to by like 2034. They're going to basically double the whole of their energy output in like 10, 15 years, I think. I'd have to look. I'll go back and find the article and put it in the show notes. But pretty interesting, because it seems like that's if that's the criteria in which we can't innovate further, is we don't have the power to power all this tech, then and other countries do, that seems like a bad place to be in as well.
Yeah, and I think there's always a concern around the cost of these things, but cost is the consequence of is a function of expertise, right? And so the first one's really expensive. The second one's a little bit less expensive. The 130th one is, a single percentage of the cost of the first one. And so, yeah, it's going to be expensive for a while, and then it will stop being expensive. But guess what? If, the Google and Amazons and Facebooks of the world want all of the power they can possibly find, they will figure out how to make it happen. Right. And that's, again, coming back to the market forces are going to solve the problem.
Yeah.
Yeah, I think we often see problems out there, and we cannot envision a possible solution in, whatever our current paradigm is. But if you look at the march of human history, we've managed to survive and continue to innovate and improve output and production. And I think this is no different, even though we can't yet see what it's going to look like. I'm pretty confident that humanity will solve the problem. Now, whether we do it equitably or whether we do it in a way that benefits everyone or just a few, that's yet to be determined. And we can look at history to give us some hints there as well. But I think we will come up with solutions. We're just still very early days.
Mm-hmm.
Yeah, I think one of us has a hard stop at coming up pretty soon. Yvonne, do we want to kind of get to the conclusion? Do we have anything else? I think. Do you got anything else, Yvonne?
And any parting thoughts, Pete?
I think the biggest piece of advice I'd have for anybody looking into space is to not get overwhelmed, because it's so much, right? And I think it's easy to look at the headlines of every component that we're worried about for acceleration and performance optimizing, and realizing each one of those thingies, somebody has a PhD and is working on it, right? And so if you're like, I don't understand how I'm supposed to understand how to write the program in C that's hardware accelerated by the GPU, and understand the GPU and its interconnect across the bus into the InfiniBand adapter, and how that adapter creates the socket, and how it does the buffer management, and oh my god, and then there's an optics thing, and I have to figure out what kind of optics and the power consumption of optical versus DAX, and this is driving me insane. Yeah, that's totally normal. Those are a whole bunch of different areas of domain expertise, and maybe find one and start there and learn the adjacent spaces, right?
You don't have a PhD in all these things, do you?
I don't even have a graduate degree. And I, as I'd like to say, I don't have a graduate degree. I've never taken a full semester of a physics class. I took chemistry in 10th grade. I don't know anything. And it's one of those spaces, even as we're having this conversation, I can't write C code. Sure as hell can't accelerate it on a GPU yet. I'm a fancy systems administrator with a networking background, and that's where I'm growing, and that's where I'm going to continue to figure out more and learn from. You can't eat the whole cake in a single bite.
Love that. So where can all the people out there find you if they don't already know?
I'm on LinkedIn. I'm the only Pete Lumbis. If there's another one, that'd be super weird to me. And I'm on Twitter at PeteCCDE.
Awesome. Thank you so much for joining us. This was a
Thanks,
great
y'all.
conversation.